Hello and welcome. This lesson is going to be about system of equations by substitution. So today is going to be the second method of how to solve system of equations, which are two or more equations. So basically, when you're trying to solve by substitution, you're looking for an equation where the letter is by itself. It doesn't matter if it's x or y. So in this particular example, I noticed that my first equation has the x by itself, so I'm going to circle it. And then, using this information, I'm going to look on the other equations and I'm going to ask, okay, on the first equation, who's the letter that is alone? Well, it's x. So under x, I'm going to put an arrow. And then I'm going to copy the 2. But instead of writing x, I'm going to replace x with negative 4y plus 24. In other words, I'm going to substitute x with negative 4y plus 24. And then I continue copying the rest of the equation. And if you notice, now I have an equation here with only one variable, which is the variable y. So now I solve the equation by eliminating parentheses, so this would be negative 8y plus 48 plus 5y equals 15. We're going to combine negative 8 with 5. That gives us negative 3y. We bring down the 48 and we bring down the 15. Next, we are going to subtract 48 from both sides. 48 goes away, so I'm left with negative 3y equals 15 minus 48 is negative 33. And we divide both sides by negative 3. And we get y equals 11. So, if we were to graph these two equations, what's going to happen is we would have two lines that cross at a point. So we just found out that the point will have an answer. So I'm going to write here answer. And the point of intersection will have 11 for the y coordinate. So now we need to find the x coordinate. In order to do that, we return to that equation that we put a circle around and we copy it. And now we have y, we're going to bring over here and we're going to substitute. And that's another reason why this is called the method of substitution, because you're substituting once and you're substituting a second time. So now we get negative 4 times 11 plus 24. Please remember, every time you substitute, put a parenthesis if you have a number in front. Like here I have negative 4y, so when I plug in the 11, there's a negative 4 in front. I need to put a parenthesis. And you can put all this in the calculator. Basically, the calculator will calculate negative 4 times 11 is negative 44, plus 24 is negative 20. So therefore, we found the x coordinate to be negative 20. So there we go. So that's the answer for this system of equations. Okay, let's go on to the next example. The next example, again, first thing I need to do is look for a letter by itself, and I notice that y is by itself. So I put a circle around it. On the other equation, I look here, okay, I have the y alone, so I'm going to put the arrow under the y. I copy everything else the same, so 2x minus 3. But when I get to that y, I open parentheses, and I'm going to put that where the y equals 2, which in this case is x plus 5 equals 9. Then I just solve the equation, so this would be 2x minus 3x minus 15 equals 9. 2 minus 3 is negative 1x minus 15 equals 9. Now I'm going to cancel the 15. So I get negative 1x equals 24. And we divide both sides by negative 1. X equals negative 24. So for this problem, I was able to find that I also have an answer. I also have a point of intersection, which will be at negative 24. and I need to find the y-coordinate. To find the y-coordinate, I go back and I copy this equation that I circled. So plus 5 right here, and I bring the negative 24. Notice here that there's no number in front of the x, so we don't need to put parentheses. You just replace negative x with negative 24. And when you do that, you will get y equals negative 19. So that means my answer is going to be negative 19 right there. So that's my answer for this problem. Very good. Let's go on to the next example. So in this example, I have a letter by itself, which is y. So since there's no space on the first equation underneath it, I'm going to just copy again. And I'm going to place the arrow under the y, because the y is the one that is alone. So now I copy everything except when I get to the arrow, I replace it with parentheses 3x plus 2, close parentheses, and I continue copying equals 4. So now I'm going to multiply, so this would be 6x, negative 2 times 3 is negative 6x, negative 2 times 2 is negative 4 equals 4. The 6x cancel, I'm left with negative 4 equals 4. So what happened here is the letter x disappear, and I'm left with a statement that says negative 4 equals positive 4. Well, upon analyzing this statement, I come to the conclusion that it's false, because a negative number is not equal to a positive number. So this is what is a special case, and that tells us that there is no solution to the system of equations. Okay, so whenever you get a false statement, it's going to be no solution. All right, let's try the next example. Again, if I see an equation with the letter alone, which in this case is x, I copy the first equation so I can have space to put my arrow. And my arrow is going to go under the x, because the x is the letter that is by itself. So then I go 4y plus 2. When I get to the arrow, I replace it with parentheses, and with negative 2y plus 6 equals 12. I'm going to eliminate parentheses, so this will be 4y minus 4y. 2 times 6 is 12 equals 12. The 4y cancels. I'm left with 12 equals 12. And again, the letter disappeared just like the previous problem, but now I'm left with a true statement, because positive 12 equals positive 12. And if that's the case, that's the situation where you have a graph on top of the other, and your answer is IMS, infinitely many solutions. Okay? So today we learned how to solve system of equations by the method called substitution. The key is to identify the equation that has the letter by itself, and once you have that, you substitute that information to the other equation. Okay, and I showed you that there's some special cases where you get no solution in IMS, and also other cases where you get a solution. I hope this video was helpful. Thank you very much for your time. Have a wonderful day. Bye-bye.